Hello, chemist. Jolly here again. This little video is going to be specifically on rotations. So I kind of showed you rotations when I was talking about chirality, but I wanted to do a couple of examples in detail. So this one is all about the rotations. And remember, beware, every time you redraw, there's a chance to make a mistake. So it's best to be able to visualize it. But let's go back to our wonderful little molecule like this. All right, I'm going to draw the mirror image. And remember, my ultimate question is, are you my non-superimposable mirror image, or did I just draw the same thing twice? All right, any rotation is valid as long as you don't make or break bonds. So I am going to pull this one down. Okay, so I'm going to do 90 degrees. Okay, I'm doing 90 degrees. And again, if you have a model kit, it makes it so much easier to see. All right. Oh, well, you know what? Let's label these A1, A2. So this is A2, A1. All right. I'm pulling A1 down right there. A2 pops up. Now B is going to stay behind, but it's going to come this direction. And C is still going to be at me, but it's going to come this direction. And lo and behold, I drew the same thing twice. So guess what? This one is a chiral, because that is not a superimposable, non-superimposable mirror image. That is a superimposable mirror image, or it means the same thing. All right, so that's like a 90-degree rotation. Let's try another one. Let's do OH, CH3. We'll do a chlorine. We'll do a bromine. All right, so again, I already see, oh, look, there's a stereo center, but that's not what I'm doing right now. So I'm going to draw my mirror image, and I'm going to use rotations to determine. Okay, so there's A and there's B. I'm wondering, did I draw the same thing twice, or is that a non-superimposable mirror image? All right, well, you know what? I'm going to 180 it. I'm going to 180 it this direction and get the same backbone. So my OH is the same, and I'm pulling the CH3 over. What was at me is now behind, and what was behind is now at me. Okay, so remember, this is still B. All I've done is rotate it. And now I have two the same. Okay, I have two the same. And these two will always be backwards of each other. Okay, so if there's four unique groups, there is my second visual for that is a non-superimposable. So this one is chiral. That one is chiral. But again, this little video is all about rotations. So I'm going to rotate it just to double check. So this time I'm going to do the steering wheel. I'm going to keep this one the same. And remember, you keep the same backbone, but I'm going to rotate this direction. So the Cl goes there, the CH3 goes there, and the bromine goes there. All right, this time, these two are the same. But this and this one are always backwards. So in this case, there's no way to rotate it to make it the same, but those are the different rotations. And one more, I can do a vertical. Okay, the OH would go down, the CH3, and then the bromine would go behind, and the chlorine would come at. So that's just a little visual on rotations. We're going to do one example of the whole thing. So I want to know, number one, is the molecule chiral? And what is the relationship between the two? All right, so here's the two molecules. Let's put an OH. We'll put an H. We'll put a Cl. And we'll put a bromine. And then this one, I'll do an H, a bromine. What am I missing? An OH. Whoops, that's a wedge. And the chlorine. Okay, this is not the mirror image. I'm giving you these two molecules. So we're going to say that one's A and that one's B. All right, now the first question, am I chiral? You can use any of those variations. You can look for the planes of symmetry. You could draw the mirror image, but I like to use the stereocenters. So look, that carbon has 4 unique groups, and there's only one stereocenter, so this one's chiral. This one has 4 unique groups, so it is also chiral. All right, question number 1 done. But I want to know the relationship. Okay, did I draw the same thing twice? Or did I draw a non-superimposable mirror image? Okay, that's the question that I'm asking. And I'm going to use rotations to determine that. All right, so we can either try and get to the same backbone like that, or we could try and get to the mirror backbone like that. It does not matter which one you do, but I'm going to go for the exact backbone. So I'm going to 180 degree this one up, okay? My hydrogen's going to stay in the same place. My bromine is now going to be up. What was at me is now behind. And OH comes up front. Okay, I now have the same backbone. But guess what? I don't have anybody the same. So I'm going to steering wheel. And you know what? I'll hold on to the bromine. Gonna hold on to that bromine. And let's go. Where do I want the OH? We'll go there. So my OH is now here. My bromine is here. Let me see who went there. My hydrogen went there. And my chlorine went there. Okay, so now I'm comparing. Remember, this is still B. I've just rotated it. Okay, my OH is the same. So this time I'm going to hold on to my OH and I'm going to steering wheel the others. And this one, the hydrogen's on the top. So I'm going to rotate up, down, and over. My OH is my fixed point. My hydrogen went up. My bromine went down. And my chlorine went over. Oh, and look at that. That is that molecule just drawn twice. So what is the relationship? Those two molecules are the same as each other. Okay. All right, that's just a little blurb on how to do the rotations. And if you can't visualize the rotations, again, a model kit, or just beware, every time you redraw, there's a chance to make a mistake. All right, let's get back out of that. All right, until next time, jolly out.